Ooh, all right. All right. Welcome back, Algebra 1, folks. We are here with problem 4-23, and I'm joined today with our favorite cousin, Mr. Chan. Mr. Chan, how are you doing today?
I am doing great, Cousin Chang.
Excellent, excellent. So, our opening problem for today is taking a look at the situation which we can solve with this equal values method of solving systems of equations. And we'll talk exactly about what that will look like and um, how we can check our work at the end as well. So in our situation here today, Mr. Chan, we have 21 animals on our farm, and we only have sheep and chickens. And we also know that if we count up all the legs of all the animals we see, there are 56 legs total. Question is, how many of each animal do we have? So I see that you drew
Cool.
a nice picture of a sheep and a chicken, and in case we weren't sure, I think we could agree that all our sheep on this farm have four legs, and all the chickens have two legs. So, can you tell us how you came up with your equations down at the bottom there?
Ah, yes, down here. At first, when I was thinking about defining my variables,
Mm-hmm.
what S and C would stand for, the choice of them just matched the name of the animals, S for sheep, C for chickens.
I think
I
that
was
makes
kind of
sense.
thinking, did I need to do like number of legs or the actual animals?
Yeah.
And as I set up my equations, I translated each of them a sentence at a time. So then here's the blue one up here that
Okay.
translated to the first equation, then the second sentence or question translated to another equation, which
All right.
often happens in these system of equation word problems.
Mm-hmm.
I just chose one and started with that, and it happened to be the right one. So here, if I define S and C as my number of chickens on the number of sheep and number of chickens on the farm,
Mm-hmm.
the first equation, well, that matches the first sentence. And then the legs part comes in as a little multiplier out here, right?
Okay.
As you mentioned earlier, every sheep has four legs and every chicken has two, giving us a total of 56. And that's how I set it up. Each sentence translated into an equation.
Cool. So I guess the first sentence or that first equation comes from how many animals, and the second equation comes from that second sentence, how many legs total.
Yeah,
All right. All right.
animals, legs. Gosh, that's quite messy. So I normally write on the chalkboard or whiteboard.
No worries, no worries, Mr. Chan. I think we can kind of understand that. I like that. Yeah. All right. So if we wanted to solve this one with equal values method, then I think we're supposed to get both of them to equal the same variable, right? So I think that
Yes.
first one is nice and clean, so it's not too difficult. Let's pretend that we want to get both of our equations to be equal to c. Then on that first one, all we have to do is that blue highlighted one. All we have to do is
Uh-huh.
subtract s from both sides, right?
Yes, and I think that's what I did down here.
Yeah, but I think that second one is definitely kind of a little spicier to work with. So you can walk us through how you did that one.
Right. Cool. So then from there, um, since I'm trying to, in this case, get C by itself, because that's my uh, equal value between my two equations,
Mm-hmm.
my first step from here down to here would be subtracting 4s from both sides.
All right, that makes sense. Try to get c by itself.
Yep. And so I'm left with this thing. But I'm still not quite there yet,
Mm-hmm.
since there's this pesky 2. So then I have to divide everything over by 2 on both sides,
Mm-hmm.
like that.
Yeah, I like
At
that.
which point,
Mm-hmm.
okay, yeah. So there's one equation over here. Here's my other one.
Awesome. Yeah. So now we have both equations equal to c.
Yes.
I think I just want to
Okay.
point out one thing that something that I think I've seen a lot, and I think you might have seen this a lot too, is that when we have that 2 times c and we're dividing to get rid of that times 2, I think I've seen a lot of folks kind of just divide maybe just the 56 by 2 or just the negative 4s by 2. And just remember, folks, that we are dividing the entire equation and thus the entire left side and the entire right side by 2. Right? Is that something you see sometimes?
Yeah. And it's a really good point that you highlight, which
Mm,
is why, like in my work here, I broke it down into these two steps when I
yeah, I like
clearly
that.
see both fractions.
Awesome, awesome. All right, cool.
So then from here,
Mhm.
right, it's what you're used to so far. It's solving um, one equation with one unknown.
Mhm.
So then in this case, I'm solving for the number of sheep, S. Because when it gets kind of messy, right? Like there's my equal value, C's in the middle. It
Right,
connects
yeah.
both sides. Yeah.
So that 21 minus S, folks, just so we're clear, that 21 minus S is equal to C, and that's right here on the left. That's equal to C, but C is also equal to this 28 minus 2S, and that's why it's dropped there on the right side. And now we can just kind of leave out the middleman, since 21 minus S must be equal to 28 minus 2S now. So that's where Mr. Chan is. All right, please continue.
Neat.
Sorry.
And then from there, we want to isolate our single variable, move things over.
Mhm.
My first step here was adding 2s to both sides and then subtracting 21, which gives me an s value of 7. Putting it back into context, that means I have 7 sheep.
I like that. Yeah, let's not forget what we're actually solving for. Awesome.
Right. Last step, because we're not quite done yet, although oftentimes, like Mr. Chang, do you find that some students just like stop here, right? I got an answer. Box, I'm
We did
done.
all that work, Mr. Chan. You're telling me we're not done yet?
Yes, we are not quite there yet. What about the number of chickens?
Right. And so we could take that 7, or there's 7 sheep, and we know that both of those equations, there's one counting the number of animals and one counting the number of legs. Since both of those are describing the same situation, we should be able to take that 7 sheep and use them in either equation to find the missing number of chickens. And so Mr. Chan wrote out here that we're going to use, I think our suggestion would, our best suggestion, excuse me, is to use the equation that's going to be simpler and less work for you. So that S plus C equals 21 total animals is way cleaner than the other one. And so if there's 7 sheep, you do the quick little mental math there. But if there's 7 sheep, then there must be 14 chickens to make 21 animals altogether. Right? If you so choose, you could plug that S equals 7 into the other equation, and you should get the same answer. But just to check, how could we confirm that 14 chickens and 7 sheep is indeed the right answer, Mr. Chan?
So from there, we use the first equation, right, the cleaner one, as Mr. Chang said, and then we got to check, do both these values, chickens being 14 and number of sheep equals 7, work for that second equation? And that's what I do over here. Here's our second equation, and all that should equal 56, which it does. You get 28 plus 28 after putting in those variables, and we've confirmed that on this farm there are 7 sheep and 14 chickens.
Boom. I like it.
All good. In summary, this is the equals values method, right?
Oh, I thought you were taking us out, Mr. Chan.
Oh, sorry. Yeah, it's the equals values method. Later, we're going to see substitution, but this is like an intro to one form of that method, and setting up equations, solving systems, and you'll get lots more practice throughout this chapter.
Excellent. Thanks for joining me, Mr. Chan.
Oh, yes, not a problem.
All right, folks. We'll catch you in the next video. Stay spicy.